Worried your EV battery will fade fast? I hear that fear all the time. Here is the truth I see on the job every day. Modern EVs lose very little range in real life. I spent over 10 years investigating EV safety and battery health, and I analyzed thousands of owner reports. The pattern is clear. Recurrent says they generally see about 1 to 2% range loss per year. Geotab's latest data puts the average close to 1.8% per year. One leader at Geotab even said most EV batteries will likely never need replacement. Stanford researchers found real driving can extend battery life by almost 40% compared to lab tests. That is huge. So today, I am ranking the top 10 electric cars that keep the most usable range after 3 years. This is real-world data, not lab guesses. Many of these cars still show 95 to 99% health after 3 years. We will count down from number 10 to number 1, and I will share battery care tips you can use right away. EV owners, what is your battery health after 3 years? Tell me your model and the percent you see. Ready to go? Let's start with number 10, where things could have been much worse, but were not. In number 10, we have the Nissan Leaf. The Leaf was the EV pioneer, and the early cars took a beating in hot climates. Here is the twist. The newer Leaf with the 40 to 62 kilowatt-hour pack uses LFP-type cells, which handle heat much better. That helps slow down aging. Even without liquid cooling, many 3-year-old Leafs I see still report around 90% or better battery health. Owners who avoid sitting at 100% and who do not quick charge every day tend to do best. A quick note on the display. The Leaf's battery management system can be conservative. It may underreport the range a bit, so what you see on the dash is not always the true state of health. Also remember, heat is the real enemy. Long exposure above about 86 degrees can speed up wear, but LFP chemistry is more tolerant. Nissan's battery warranty, often 8 years or 100,000 miles, adds peace of mind for shoppers. If I were buying used, I would check the car's climate history and charging habits. The Leaf proves older fears do not define newer tech. Up next, number 9. A recall story that turned into a long life win. In number 9, we have the Chevrolet Bolt EV. This car was a range bargain, then came the well-known battery recall. Here is the good news. GM replaced many early packs with improved cells, and that helped both safety and longevity. After 3 years, many Bolts I review still hold roughly 90 to 95% of their original range. Active liquid cooling in the Bolt's 60 to 66 kilowatt-hour pack slows down heat-driven wear, and it shows. Real-world surveys back this up. Recurrent tracked thousands of cars and found pack replacements are rare events. Only about 1.5% of a large sample needed a new battery, and most of those were older, early models across brands. The Bolt's numbers line up with what fleets are seeing too. Modern packs almost never fail in the first 5 years when cared for. If you are buying a used Bolt, check the service records to confirm the recall work and any battery updates. Also ask how often the owner fast-charged and where the car lived. Hot climate plus constant 100% charges can shave off a few extra points over time. The Bolt bounced back well. Now, number 8 brings a big battery and a smart twist. In number 8, we have the Volkswagen ID.4. Many folks assume this one fades fast. In practice, it does not. The ID.4 uses a large NMC battery with full liquid cooling, and newer trims add a heat pump. Put that together, and you get slow, steady aging. Geotab's analysis of fleets shows modern liquid-cooled EVs often lose about 1 to 2% per year. Owner reports I review match that. After 3 years, a typical ID.4 still shows around 94 to 97% capacity in moderate climates. Cold weather cuts range on the day, but that loss is mostly temporary from cabin heat use. In hot regions, sustained temps above about 86 degrees can speed up aging, but the thermal system works hard to protect the cells. I often see only a single-digit kilowatt-hour drop after 3 years of mixed driving, which is very solid for a family SUV. VW backs the battery for 8 years, or 100,000 miles, another sign of confidence. If you drive long trips, watch your projected range year over year. It should barely move if you care for it. The ID.4 is steady and calm. Next, number 7. A small Hyundai that punches way above its weight. In number 7, we have the Hyundai Kona Electric. Here is the surprise. There is no heat pump on many trims, yet the Kona still holds a high percent of its original range. Why? Quiet advantages. The 64 kilowatt-hour pack is big for a compact, and it is liquid-cooled and well-insulated. Bigger packs spread the work across more cells, which helps them age slower. Across fleets and owners, I often see only about 1 to 2% loss per year. After 3 years, many Konas sit around 94 to 96% health, and some do even better. Cold weather can make the gauge dip, but most of that is temporary. Cabin heat and cold cells lower efficiency that day, not the long-term capacity. Power delivery stays strong too. In EVs, loss of storage is the main issue we watch. True power fade is rarely the limiter at this age. Want to help your Kona last? Keep daily charging around 80%, precondition in winter, and save full charges for trips. The Kona's design proves you do not need fancy features to keep a healthy pack. Up next, number 6. The Kia twin that matches the Kona on tech and sometimes beats it in real-world results. In number 6, we have the Kia Niro EV. It shares the platform and the 64 kilowatt-hour pack with the Kona, and it brings the same liquid cooling and smart insulation. Yet many Niro owners I speak with report almost no noticeable range drop after 3 years. Seeing 97%, even 99% is not unusual with moderate use. Part of this may be the way Kia tunes the battery management system. It is conservative, which keeps the cells away from stress points. Geotab's fleet work found something that surprised many drivers. High-use EVs did not degrade much faster than low-use cars. That means daily commuters can rack up miles without wrecking the pack, as long as they avoid heat and extremes. Want an easy habit that pays off? Charge day-to-day to about 80%. Do not let the car sit at 100% for days. Save fast. DC charging for trips. If you are shopping used, ask for the battery health readout, charging history, and climate exposure. Before we jump into the top 5, quick pit stop. If this helps you drive smarter, tap subscribe to Recall Roadmap with Morgan for calm, real-world safety, and battery tips. Now, number 5 is a bold Ford that plays the heat game well. In number 5, we have the Ford Mustang Mach-E. This was Ford taking a big swing, and the battery team got the basics right. You get a liquid-cooled pack, and, on newer models, a heat pump. That matters because cabin heat is a huge winter energy draw. A heat pump reuses warmth from the drive system and the air, so the battery does not have to work as hard. Less stress means slower aging. Early owner data I review, including cars past 3 years and tens of thousands of miles, points to very low degradation. Often it is under 5% by year 3. Geotab's large study even placed top EVs like this at about 1% loss per year under typical use. Ford's battery management is also careful about high and low extremes, which helps preserve capacity. If you drive rideshare or spend a lot of time on the highway, do not worry. Evidence shows high mileage alone does not crush a healthy pack. Keep daily charging around 80%, precondition before fast charging, and your Mach-E should hold up. Now, number 4. The Tesla that made EVs common, and it keeps its range shockingly well. In number 4, we have the Tesla Model 3 Long Range. People ask me all the time, will my Model 3 lose a lot of range? The data says no. Recurrent's real owner tracking shows only a few % drop in the first 3 years. On average, I see around 6% loss by year 3. Tesla uses a large pack with advanced chemistry and full liquid cooling, and their software keeps the cells away from risky extremes unless you ask for it. One note on the display: Tesla can mask some temperature effects, so the estimate you see is not always the true state of health. If you are curious, a service visit or a trusted app can give a clear battery health view. Long-term, Tesla's large cars show only about 12% loss, even past 200,000 miles, which fits with this early gentle slope. Daily care still matters. Keep your charge limit near 80% for normal driving, precondition before a fast charge, and avoid letting the car sit full or empty. The Model 3 proves smart thermal management pays off for years. Up next, number 3, a taller Tesla with a heat pump that does even better for many owners. In number 3, we have the Tesla Model Y. Think of it as a taller Model 3 with a big advantage. The Y brought a heat pump early, and that reduces winter drain and battery stress. In the owner data I track, the Y often loses only about 2 to 4% in 3 years. Many sit at 96 to 98% health with mixed use. The pack is liquid-cooled, the thermal controls are quick, and Tesla keeps the chemistry in a comfortable window. Here is a neat insight. Time can matter as much as miles. Studies show calendar age drives a lot of the early fade, so light drivers should still follow good habits. Heat speeds up wear, especially above about 86 degrees. If you live hot, park in shade, use scheduled charging to finish near departure, and keep the state of charge moderate. In cold places, the heat pump and preconditioning keep the pack happy. The result is one of the lowest real-world fade rates in the industry. The Model Y shrugs off daily life. Now, number 2 is a legend with a massive pack that turns slow aging into an art. In number 2, we have the Tesla Model S. This car launched the modern EV era and still sets the bar for pack life. With roughly 100 kilowatt-hours on board and robust liquid cooling and heating, the S ages very slowly. Owner reports I see often show more than 95% capacity remaining after 3 years. Long-term studies back it up. Across very high mileage, S and X average only about 12% loss, even after 200,000 miles. Scale that down, and 3 years of normal use often looks like only 3 to 5% gone. Big packs help because each mile uses a smaller slice of total capacity. The battery management is also protective, catching temperature swings and avoiding voltage extremes. Remember this when shopping. Even if an S shows 90% state of health, that is still about 90 kilowatt-hours, which is more energy than many smaller EVs had when new. Ask the seller for a battery health report, charging history, and any thermal system service. The Model S proves that size and smart cooling make a long-life combo. Now, number 1. A heavier Tesla that somehow holds on just as well, and sometimes even better. In number 1, we have the Tesla Model X. Big, bold, and heavy, yet it barely ages. The X shares the huge pack and liquid cooling approach with the S, and many owners report results at the very top of the field. In the data I see, a 3-year-old Model X often shows around 95 to 98% capacity remaining. That lines up with the best cases in fleet studies, where top EVs lose about 1% per year when managed well. Why does the X do so well? Sheer battery size helps, and Tesla's thermal system keeps cell temperatures steady even under heavy loads. The battery management avoids the edges unless you need them. Owners using long trips and fast charging still see slow, predictable aging when they avoid sitting full and keep the pack cool. Recurrent's owner checks often flag the X green at the 3-year mark. In plain words, the range feels almost like new. That is why the X sits at number 1 for range retention after 3 years. You have seen the list. Now let me give you quick steps to protect your pack and shop smarter for a used EV. We set out to find which EVs keep real-world range after 3 years, and the results were better than the fear. Most modern EVs lose only a few percent a year. Geotab's data lands near 1.8% per year on average, and Recurrent says they generally see about 1 to 2%. Models with liquid cooling, large packs, and heat pumps sit at the top. Even our number 10 still held around 90%. Reality beats the myth. Here is how to use this. First, check battery warranty and recalls before you buy used. Run the VIN on the official recall site and the brand's owner portal. Ask for service records and a battery health report. Look for signs of heavy fast charging and long hot parking. Confirm thermal features like liquid cooling and a heat pump. On day 1, set a daily charge limit near 80%, precondition before fast charging, and avoid letting the car sit full or empty. Keep it cool in summer and warm in winter. If this helped, please subscribe to Recall Roadmap with Morgan, drop a like, and share with a friend who is shopping used. Thanks for watching. Think about your own car. Which matters more to you, a big battery or liquid cooling, and would you buy based on battery health?